Let me begin with something very simple, so simple that it almost sounds silly, and yet once you hear it, it has a way of refusing to leave your mind. Why do atoms exist at all? Not how they exist, not what they are made of, but why they are allowed to exist in the first place. Because if you pause for a moment and really think about it, atoms shouldn't exist. At least not according to the way most of us imagine the world works. We are told that atoms are made of parts that attract each other. Strongly, incredibly strongly, much stronger than gravity, stronger than magnets, stronger than almost anything we encounter in daily life. So if attraction is the rule, then collapse should be the outcome. That seems obvious. When things attract each other, they move closer. If nothing stops them, they keep moving closer. They don't politely stop at a comfortable distance. They don't pause because things look stable enough. Attraction has no built-in brake. So why didn't atoms simply collapse? Why didn't electrons fall straight into the nucleus and stay there forever? Why didn't matter shrink down into tiny, dense lumps long before stars, planets, or people ever appeared? Most of us were never encouraged to ask this question. We were shown diagrams instead. Clean pictures, little circles, little orbits, everything neat and controlled. And we were told more or less, this is how atoms are, and then we moved on. But those pictures hide the real mystery, because they quietly assume stability without explaining it. They assume atoms already exist and then describe their behavior. But the deeper question comes earlier. Why is there anything stable to describe at all? If you grew up believing that solidity comes from firmness, that stability comes from stillness, that things exist because they are strong enough to resist change, then atoms should make perfect sense. But the universe does not work that way. Atoms are not strong little objects holding themselves together. They are fragile balances. They exist not because they are powerful, but because they are constrained. And that difference changes everything. Imagine holding a spring in your hands. You compress it. It pushes back. Not because it wants to, but because compression creates resistance. Now imagine pushing harder and harder. The resistance increases. There is a cost to squeezing. Now imagine this not as a mechanical spring, but as a rule of reality itself. A rule that says if you try to confine something too tightly, it will push back. That rule is not optional. It's not a preference. It's built in. Electrons are not tiny balls flying around like planets. They are more like patterns of possibility. And when you try to trap those possibilities into a tiny region, the universe charges you a price. This is where the usual explanation quietly falls apart. We are often told that electrons don't fall into the nucleus because they are moving, but moving objects fall all the time. Planets fall, satellites fall. Everything that moves under attraction eventually falls if nothing prevents it. So motion alone cannot be the answer. The real answer is stranger. The universe does not allow perfect confinement. It does not allow exact stillness. It does not allow everything to be known and pinned down at once. And the harder you try, the more resistance you encounter. Atoms exist right at the point where attraction says collapse, and the rules say that will cost too much. So collapse doesn't happen. Not because it's impossible, but because it's forbidden by balance. This means atoms are not objects in the ordinary sense. They are negotiations, agreements enforced by the structure of reality, a quiet compromise between what forces want to do and what the rules allow them to do. That should feel unsettling, because it means the solid world around you is not solid in the way you think. Your chair is not solid because it is packed full of matter. It is solid because the rules of interaction make it behave that way. Your hand doesn't pass through the table not because the table is dense, but because the patterns inside both your hand and the table resist overlap. Solidity is not substance, it's behavior, and behavior depends on rules. Once you see this, common sense starts to crack, because common sense says that stability comes from rest, from things settling down, from motion ending. But atoms tell us the opposite story. Stability comes from motion that cannot be stopped, from restlessness that cannot be removed, from uncertainty that cannot be eliminated. Atoms are stable because they are never perfectly still. That's not poetry. That's the core of the matter. And once you accept that, you start to see why textbooks struggle to explain this clearly. Because the truth sounds backward. It sounds like nonsense at first. It contradicts everything we learned by pushing objects around in the physical world. Yet the universe insists atoms exist not because they make sense to us, but because the universe follows rules deeper than intuition. And this is only the beginning. Because once we understand that atoms exist due to balance and restriction, we are forced to ask a much larger question. If reality is built this way at its foundation, what does that say about everything else? About matter, about life, about us, and that's where we'll go next. So let's continue, but let's not rush, because this part is where the idea really starts to stretch your intuition. When people first hear that electrons don't fall into the nucleus, they usually imagine some hidden support, some invisible floor, some force holding things apart the way a table holds a book. But there is no floor inside an atom. There is nothing holding electrons up. There is no tiny scaffold keeping things in place. Instead, there is something far stranger at work. Imagine trying to hold water in your hands. You squeeze your fingers together. The harder you squeeze, the more the water slips out. Not because the water is clever, but because confinement creates pressure. The act of squeezing changes the situation itself. Now replace water with an electron. The more tightly you try to pin it down, the more restless it becomes, the more energy the situation demands. The universe doesn't say, you can't do that. It says, you can, but it will cost you. And atoms exist right at the point where that cost becomes too high. This is why electrons don't fall in. Not because they are prevented, but because collapsing further would require more energy than the system can afford. That's a very different kind of explanation than most people expect. We're used to thinking in terms of pushes and pulls. Forces pushing things away. Forces pulling things together. But here, the resistance is not a push in space. It's a resistance in possibly. Thank you. The universe resists being too precise. It resists being pinned down. It resists perfect stillness. This resistance doesn't show up in your daily life because everything around you is huge compared to atoms. By the time you're dealing with tables and chairs, all this subtle balancing has already settled into patterns that feel solid and obvious. But at the atomic scale, nothing is obvious. An atom is not a tiny solar system. It's more like a standing wave, a stable pattern that exists because certain arrangements are allowed and others are too expensive to maintain. Think of a guitar string. You pluck it. Certain vibrations survive. Others disappear. Not because someone chose them, but because the system allows only certain patterns to persist. Atoms work like that. Only certain patterns of motion and uncertainty can survive. Everything else collapses or flies apart. So when we ask why atoms exist, the honest answer is not because of force, but because of permitted patterns. And that changes the story completely. It means matter is not built from tiny hard pieces. It's built from allowed behaviors, from arrangements that satisfy the rules of reality. This also explains something else you may have wondered about. Why does empty space feel empty, but solid objects feel solid? After all, atoms are mostly empty space. If you look at their size compared to the space inside them, solidity should not exist at all. You should fall through the floor like a ghost. But you don't. Because solidity is not about filling space, it's about interaction. When your hand approaches a table, the patterns inside your hand and the patterns inside the table begin to assist each other, not by touching, but by refusing to occupy the same state. They push back not because they are hard, but because the rules forbid overlap. So solidity is not a material property, it's a rule-based outcome. This is why atoms feel so unintuitive. Everything you experience directly is an emergent effect, a large-scale behavior built on countless tiny negotiations you never see. And yet, your entire existence depends on those negotiations working perfectly. Every chemical bond, every breath, every thought, every memory. All of it relies on electrons refusing to collapse and atoms maintaining their delicate balance. And here's the part that really shifts perspective. Nothing in this story involves intention. Atoms don't want to exist. Electrons don't try to stay apart. The universe doesn't care about stability or life or beauty. It simply follows its rules, and those rules happen to allow structure, That's both humbling and astonishing. Humbling because it means existence is not guaranteed. Astonishing because it means so much can emerge from such simple constraints. Balance creates space for complexity. Restriction creates room for structure. Limits create possibility. And once you see that, you realize atoms are not special exceptions. They are the first place where this pattern becomes visible. The same idea shows up everywhere else in physics. Stars exist because inward collapse and outward pressure balance. Planets survive because falling and escaping are both limited. Even the universe itself seems to hover between flying apart and collapsing inward. Reality is built on edges, and atoms are the smallest edge we can touch. This brings us to a deeper question, one that physics cannot fully answer. Why are the rules like this? Why does the universe forbid perfect stillness? Why does it resist total collapse? Why does balance exist at all? Physics can describe how atoms work with incredible precision. It can predict outcomes. It can build technologies. It can explain patterns. But it cannot tell us why these rules exist instead of others. And that's not a weakness. That's a reminder that understanding is layered, that explanation has depth, that no matter how far we go, there will always be questions left open. And that brings us to the final part. Because once you understand why atoms exist, you start to see that the lesson is not really about atoms at all. It's about reality and about us. Now we arrive at the quiet part of the story. The part where the equations, the pictures, the explanations all step back, and we're left with something more uncomfortable and more honest. Because once you understand why atoms exist, you realize you haven't actually been given a comforting answer. You've been given a deeper question. Atoms exist because the universe does not allow extremes. It does not allow perfect collapse, and it does not allow unlimited freedom. It forces everything to live in between, in balance, under restriction. And that's not what we were taught to expect. We were taught that things exist because they are solid, because they are strong, because they are made of stuff. But atoms show us that existence is not about stuff. It's about rules, rules that don't ask our permission. Rules that don't explain themselves. Rules that simply are. Think about how strange that is. Everything you see, touch, and care about depends on electrons refusing to behave the way common sense says they should. Your body exists because collapse is forbidden. Your thoughts exist because uncertainty is unavoidable. Your memories exist because perfect stillness is impossible. You are not built on certainty. You are built on limits. And those limits are not flaws. They are the reason anything can persist at all. This changes the way you look at stability. Stability is not something achieved by freezing things in place. It's something achieved by allowing motion within boundaries. A river is stable not because the water stops, but because it keeps flowing within its banks. Remove the banks, and the river disappears. Freeze the water, and the river disappears. Atoms are rivers of possibility. They exist because reality provides banks. And once you see this, it becomes impossible to unsee the pattern elsewhere. Stars live on the edge between collapse and explosion. Too much gravity, and they die inward. Too much outward pressure, and they tear themselves apart. Life survives on the edge between order and chaos. Too much order, and nothing adapts. Too much chaos, and nothing lasts. Even understanding itself works this way. Too much certainty, and curiosity dies. Too much doubt, and meaning dissolves. Knowledge lives in balance. So when we ask, why do atoms exist, we are really asking, why does balance exist at all? And here physics reaches its honest limit. Physics can tell us how balance works. It can tell us what happens when we disturb it. It can describe the rules with astonishing accuracy, but it cannot tell us why those rules exist instead of others, and perhaps it never will. This is not a failure of science. It's a boundary of explanation. And boundaries are not something to fear. They are something to respect. Feynman understood this deeply. He was never troubled by not knowing the final answer. What troubled him was pretending that the mystery wasn't there. He believed that the real joy of physics was in seeing how strange the world actually is, not in forcing it to fit our expectations. Atoms don't exist because they make sense to us. They exist because the universe is self-consistent. And we are lucky enough to live inside that consistency. The next time you touch something solid, remember that it is not solid in the way you think. It is a carefully maintained balance of restlessness. The next time you feel grounded, remember that the ground beneath you is mostly empty space held together by rules you cannot see. And the next time you wonder about your place in the universe, remember this: the same rules that prevent atoms from collapsing also allow you to exist long enough to ask questions. You are not separate from these laws. You are an expression of them. Atoms shouldn't exist, and yet they do, not because the universe promised them a place, but because balance made one possible. And perhaps that is the most honest lesson physics has to offer: that existence is not guaranteed, that stability is not permanent, that understanding is never complete, and that the universe, at its deepest level, is not something to be conquered or simplified, but something to be wondered at. So don't rush to close the book. Don't rush to feel satisfied. Let the question stay open. Why do atoms exist? And what does it mean that they do?